Okay, now since all of my projects are based on putting bootloaders in Atmel chips and making little boards such as this or this one. Hello, camera's here. There we are. Alright. And here's a nice little one here. Okay. I have to get the software into the chip once it's on the board. Since the hardware is always so simple that it's so dependent on software, basically other than a little bit of prototyping to make sure I know how to access certain new parts, I simply wire it all up, get the boards made, and then start doing the software from there. Okay, now, how to get the software to the board? Well, here we go. A little tiny, fairly cheap USB to serial connector. Pretty standard pinout on a lot of these. And that's what I've drawn here, okay? Now, here's an example. Here's the circuit board with one of the chips on it. Kind of generically here. Could be any of the Atmel chips. With the bootloader in it. So, here's the edge of the board where the connector is. And that's designating this 6-pin connector here, which is 1-to-1 wired with this one over here. So basically, here's the connections. You hook a ground wire up. Now, the power VCC is optional. Sometimes you want to power this separately, which is what it's going to do in the end. But sometimes it's convenient while doing development to power from here. But I come through a Schottky diode. That makes sure that if I hook the power up here while this is connected, this doesn't back up here and fight this thing, which could be a problem. So you lose about 0.2 of a volt, but that will still run this. The TXD goes to the RXD on the particular chip. The RXD, of course, goes to the TXD. Now, the DTR line is special on this, just like the original Arduino design. The DTR signal actually exists for the entire upload time. Well, you can't use that for a reset, or the processor would be in reset the whole time. By going through a 0.1 microfarad capacitor, you get only a temporary reset pulse. Then, during the rest of this time, the upload happens. Now, the trouble is this other edge here. Since this is up at this level, when it hits this edge, goes through a capacitor, it'll spike up to 10 volts, which is probably not good, and I find it makes these things erratic for uploading. That's what this diode does. Now, additionally, some devices have also resistor, but there is a pull-up in here, which seems quite adequate. So that's this setup here. Once this is set up, it runs just like you're running an Uno or a Nano. You just sit back, write code, hit the upload button, and wonder why it still doesn't work. Now, the other way to get it in is to use a protoclip. Here's a 14-pin protoclip. This is wired up for the AT-Tiny 84, which one of my favorite chips. Okay. Now, this is going to go from there directly onto the chip. Because of that, you can't put the capacitor and diode on the board because you're coming in right at the chip. In theory, you could put the diode on the board. I think I've done that sometime. But basically, you put the capacitor in line. Okay, and it's in line here someplace. Where did I put it? Oh, back here. Okay, we got it in line. Little capacitor heat shrink there. And I put the diode here. So some of my boards I've laid out, I didn't have the diode because I didn't learn till later that you really had to have that. So this will work in either case. Okay, now on here, it turns out, which by the way, documentation I had to trace out, when you're programming the AT Mega 328 chip, you know where the send and receive lines are because they're hardware and they're in specified pins. When you put the Optiboot, and this is all based on Optiboot, I had to chase down. Now, later I found the website that's got all this information on. So what happens here is the usual connections, the ground, the same kind of VCC connection, the same optional connections here. The TXD goes to pin 12, and pin 12 here, TXD pin 12, turns out pin 12 is the RXD here. And likewise the RXD goes here, 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 and this pin here is its TXD on 11 and 12. Had a hard time finding the first one. Like I say, I'll show you a link to the GitHub page which has all of the connections and all of the pinouts for a bunch of all of these chips. Lastly, the real cutie pie here is the 85, which, although you tie up a couple of the lines to get the upload to happen, you can sometimes still use those for certain purposes, even while they're tied to this, depending. For instance, the RXD line here is a very light load, and so pin 5 here, when it's actually running and not in the upload Optiboot function, can be anything. But you can't use this one here because it's being sent a TXD signal, which will simply try to hold it high. There's ways to get around that, but let's keep it simple for now. Okay, so here's the little connector for that. Now this one doesn't have the diode on, but most of my boards, by the time I got to that, I had learned to put the diode on, although it's not mounted yet. It's going to be on the board, because the diode can mount on the board because it's in parallel with everything else. But the capacitor still has to be in line because you're going to clip right onto the chip. Okay, well that's our hookup here. And just for reference, in case you want to start working with this, RXD would have to be TXD, so TXD is on 5. Okay. And that leaves RXD on 6. So you come in 5 and 6, and of course pin 1 is the reset pin. And that's it. That's how we get hooked up, and hope that helps you out.